we have a easy but a little bit conceptual question. It says that you have a quadratic equation px is 0. It has real coefficient and it is telling you that it has purely imaginary roots. Now they are looking whether it has purely imaginary roots or real roots or something like that. What do we do? Okay, we can start with an example. Let's say, okay, see what's the scene. Give me an equation which has purely imaginary roots. Okay, the simplest one. Okay, we have to work with the simplest one. Let's work with x squared plus 1. You know the roots, right? You know the roots of this equation is plus or minus I, or roots would be plus and minus I. But what are we interested in? We are interested in p of px is equal to 0. Okay, so let's do that. Now if I am working with the same example, what do I end up in getting? Yeah, because you see, instead of x you have a px now, so the solution would give you px is equal to plus and minus I, right? Now let's just go forward and try to solve this. Okay, the px, okay, px which you have taken is x squared plus 1 is equal to plus and minus I. Let's solve for x. You subtract a 1 on both sides, so minus 1 plus minus I. Now still not done, you have to take a square root, so minus 1 plus I. Okay, that's from here you get two solutions, and minus 1 minus I power half. Here, from here also you get two solutions. Okay, now the question is, when can these be purely imaginary or can these be real? Okay, or something like that. Okay, see, look at the options. So what do we answer? The answer is straight no. Okay, they can't be purely imaginary or they can't be real. Okay, they have to be, like, D is the correct option. Okay, but how do I know that? Okay, if you know the geometry of complex number, it will be very clear to you. So what's happening here is, you look at what is this point. X is negative 1, that's the real axis, and y is positive 1, that's the imaginary axis. Okay, so your complex number is somewhere here. Okay, now if I try to denote it like as in a polar form, okay, so this is your complex number. Okay, and polar form, that means this is theta and this is r. So you write, now I'm not trying to figure out what is theta and what is r, because we have to just need to know whether it would be real or purely imaginary or not. Okay, so this is my number. Okay, I have written this, let's say, in the this form. Okay, now what happens when you want to take a square root? Okay, so you have to have a power half. You can use de Moivre's. Okay, let's write just one root. Okay, there are two roots, let's write just one. Okay, I can put that half inside. Theta by 2 plus I sine theta by 2. Now what is happening, you see, that if this is theta, your theta by 2 is somewhere here, right? Okay, I don't know, I mean, you have to just get r root r also. Okay, the distance. Okay, anyways, this is theta by 2. Okay, the moral of the story is that you are not on the imaginary axis, neither you are on the real axis. Okay, you are somewhere here. Okay, so it can't be purely imaginary or real number. Okay, the other root also will lie somewhere here, right? You know that, you just need to add a pi to that. Okay, that also is not on the real axis nor on the imaginary axis. Okay, and exactly the same thing you can argue with this number. Okay, so your D options happens to be the correct option with the geometry of complex number. Okay, I will see you with the next question.